The Influence of Dietary Constituents on the Olfactory Profiles of Human Flatulence by Azlan Adnan M.A. Sunday, 24 of August, 2025. Abstract: Flatulence, although often trivialized socially, provides valuable insight into the interactions between food, digestion, microbial metabolism, and the volatile compounds released in the human colon. The majority of intestinal gas is odorless, consisting mainly of nitrogen, oxygen, carbon dioxide, hydrogen, and methane. Yet it is the small fraction of volatile organic compounds, especially sulfur and nitrogen-containing molecules, that determines its distinctive fragrance. This paper examines how different foods, including legumes, cruciferous vegetables, shellfish, dairy, spices, and the allium family, influence the olfactory profile of human flatus. The general composition of intestinal gas. Most gas produced in the gut carries no scent at all. The air expelled is primarily nitrogen and carbon dioxide, with hydrogen and methane depending on the balance of fermentative bacteria present. The odor is created not by these gases, but by a complex mixture of volatile compounds released in trace amounts, many of them the byproducts of microbial action on indigestible carbohydrates, proteins, and other dietary constituents. Legumes and pulses. Legumes such as beans and lentils are often blamed for excessive wind. They contain fermentable oligosaccharides such as raffinose and stachyose, which human enzymes cannot digest in the small intestine. When they reach the colon, bacteria break them down into hydrogen, carbon dioxide, and methane. The result is voluminous, but generally mild-smelling flatulence. Only when combined with sulfur-rich proteins do legumes contribute significantly to odor through the additional formation of indole and skatole, musky compounds derived from tryptophan metabolism. Cruciferous vegetables. Cabbage, broccoli, Brussels sprouts, and other crucifers owe their strong effect on flatulence odor to their high content of glucosinolates. Once metabolized by gut bacteria, these yield hydrogen sulfide, methanethiol, and dimethyl sulfide. The consequence is the unmistakable rotten egg quality of crucifer-induced flatulence, which is often more striking than the sheer quantity of gas produced. Shellfish and chitin. When prawns and similar shellfish are eaten with their chitinous shells, the resulting flatulence is especially memorable. Chitin is a tough polysaccharide that humans cannot digest. In the colon, specialized bacteria partially ferment it, releasing short-chain fatty acids along with ammonia and other nitrogenous byproducts. At the same time, shellfish proteins, which are rich in sulfur-containing amino acids, are degraded to yield hydrogen sulfide and other sulfur volatiles. Most distinctive, however, is the production of trimethylamine, putrescine, and cadaverine, biogenic amines also associated with the smell of decomposing seafood. Combined with indole and skatole from protein putrefaction, the result is a flatulence profile with an unmistakable fishy, decaying, sulfurous character. Dairy. For individuals with lactose maldigestion, dairy products often trigger flatulence with a sour or rancid edge. Lactose that is not digested in the small intestine undergoes bacterial fermentation in the colon. This produces hydrogen and carbon dioxide along with lactic and acetic acids. Although the volume of gas may not be extraordinary, the acidity of the volatiles gives dairy-related flatus its distinctive tang. Spices and aromatics. The effect of spices is subtler but nevertheless perceptible. Volatile oils from cumin, fenugreek, curry leaves, and other seasonings may not only flavor food, but also influence the scent of flatulence. Some of these aromatic molecules pass through digestion relatively unchanged, lending a recognizable culinary note to the odor of expelled gas. In such cases, the fragrance of Flatus mirrors, in miniature, the fragrance of the meal itself. The allium family foods from the allium family, garlic, onions, leeks, shallots, and chives, are among the most potent modifiers of flatulent odor. They are abundant in sulfur-containing precursors such as allium, which, when enzymatically converted to allicin and further metabolized, give rise to allyl sulfides and other strong-smelling compounds. In the colon, bacterial breakdown releases hydrogen sulfide, methanethiol, and allyl methyl sulfide. These volatiles are particularly pungent and persistent. Notably, allyl methyl sulfide is not fully metabolized in the body and is exhaled in the breath as well as secreted in sweat, amplifying the overall sensory impression of garlic-rich diets. In flatulence, the effect is an especially penetrating, sulphurous odor that tends to linger longer than that from cruciferous vegetables. Individual variation. The precise olfactory character of flatulence differs considerably from person to person. This variation depends on the composition of the gut microbiome, the rate at which food transits the intestines, and the specific combinations of foods consumed. A diet high in fermentable carbohydrates may produce large quantities of odorless gas, whereas sulfur-rich proteins yield smaller amounts of gas that are disproportionately pungent. Chitin and seafood proteins, meanwhile, add a fishy or putrefactive signature that is readily distinguished from other sources. Conclusion. The fragrance of human flatulence is neither random nor trivial. It is a predictable outcome of diet interacting with microbiology and physiology. Legumes contribute volume more than odor. Crucifers create sulphurous rotten egg notes. Shellfish with chitin produce an unmistakable fishy, decaying aroma through amine and sulfide formation. Dairy in lactose maldigestion yields a sour profile. Spices overlay their distinctive aromatic signatures, and the allium family imparts some of the most powerful and enduring sulphurous odors known in diet-related flatulence. Understanding these processes demystifies an everyday phenomenon and highlights the intimate connection between what we eat, how our microbes metabolize it, and how the results announce themselves to the world.
Share your thoughts in the comments below. Don't forget to like this video and subscribe to our channel to show your support.